today I'm going to talk about index tuning once again. We have a couple of videos already in this channel on index tuning, and this one is specifically inspired by one recent case that I saw with a customer. So when you have to create single column indexes, things are pretty simple. It's less complicated because you have to deal with a single column or a single key. But the moment you create a non-clustered index with multiple columns, that is, your index key has multiple columns, and let's say you're trying to do something with a covering index, and then you also have to use the include keyword, then things get a little complicated. So this demo is specifically going to focus on multi-column non-clustered index, and I'm going to talk about the order of columns and the sort order and how do you deal with that. So it's a simple example, yet if something like this is happening in your environment, you may want to go ahead and fix it. If you wish to stay connected with me, you can subscribe to this exclusive distribution list, Connect with AB. Members of this distribution list are people who have watched my videos or read a blog or even attended pre-cons or a session at a conference. And I also have members from all my master classes in this distribution list. So yes, this distribution list is pretty exclusive. The link is available in the YouTube description. You can also follow me on Twitter, _Bansal. Let's get started with the demo now. Let's get started with the demo, and we are going to use AdventureWorks for this demo. And I will also turn on statistics, time, and IO just to show you a few metrics. And we're going to play with this table, sales order header, which is in sales schema. And specifically, we're going to play with these two columns, customer ID and salesperson ID. Now, when I say we're going to play, which means I'm going to use these two columns in my select queries. Before we start playing around, let's go and see what indexes already exist on sales order header, and we'll use SP help index to quickly see. It just takes a bit of time because execution plan is turned on and it gives me the execution plan for the SP help index. Well, I don't need that. Let's go back to the results there, and amongst many indexes that are there, you will notice that there is an index on customer ID already. So that's a non-clustered index, and there's another non-clustered index on salesperson ID. So remember that. One exclusive index for customer ID, another one for salesperson ID. But there is no non-clustered index where both the columns are included together in a composite format. So keep that in mind. Let's go back, and now let's start running our queries. So the first one is very simple. Select customer ID, salesperson ID from the table, and this means I just want these two columns, and I'm asking for all the rows. Now remember, there are 31,000 rows there, and I just did a select star without any predicate, and this of course without it's a no-brainer. I get a clustered index scan, which means the entire clustered index object, which is the table itself, every page is being touched by SQL Server here, and you can see that the sales, this is the clustered index that is being scanned, and you get these two columns as the output. We didn't ask for any specific order, so ordered says as false. So whichever order the pages are in, they would come in. So that is the case with the first one. Now let's tweak the query a bit, and this time we will include a predicate where customer ID is equal to 1. And let's execute this, and we will get only 4 records. Now remember, this may play an important role here in terms of selectivity. This table has about 30,000 records, and this query only gets 4 records, which means the query is highly selective. This is something that you need to keep in mind. And when you look into the execution plan, now you get a different plan, obviously because there is a predicate, and now SQL Server can actually seek on one of these indexes that we saw earlier on customer ID. So it seeks on customer ID, and then for every record that it gets from the index, it will do a bookmark lookup on the base table and get you the salesperson ID. This is what happens. And then you can see the number of executions. Bookmark lookup executes this iterator runs for 4 times because there are 4 records. Now, why has SQL Server done this? Well, simply because it thinks that This time only for 4 records, scanning the entire table is not going to be cost effective. Instead, let's go and do a key lookup and get the data out. But things will change again if you say customer ID greater than 1, which simply means that I'm trying to get all the records once again. And technically this is like a range scan. It goes to that 1 and starts scanning from that point. It all turns out to be that there's no separate iterator for a range scan, and then again clustered index scan is going to be used as an iterator, and because we are fetching all the data once again, 31,000 records. So all good there. Optimizer is making the right choices. Now this is what I want to do. You see, when we ran this query, and if you look into the messages, the logical reads here is 706, which means we were definitely touching every page. And this is let's say a large table in terms of the number of columns, and you only want 2 columns. Why not think about creating a covering index? And because I am only filtering on customer ID, which means I'm only seeking on customer ID, I can create a covering index and put customer ID as the key column, and let's say put sales person ID in my include keyword. And the purpose of putting this in include is salesperson ID will only remain in the leaf level, and it won't exist in the root page or the intermediate page. And when you execute this, let's go and create the index. And now we expect that SQL Server will use covering 1 because both the columns are available in this index covering 1, and you're only filtering on customer ID. So let's hope, and we get all the data again, and let's go into the execution plan, and you can see, yes, Optimizer does use covering 1 beautifully. Absolutely no brainer till now, until now things have been pretty simple and straightforward. Remember friends, we are in the middle of the demo, and yet I haven't come to the point because I just want to do a bit of background there. Now comes another tricky aspect. Now I also want to filter on salesperson ID, but remember, salesperson ID is not in the index key formation. It's only there at the leaf level. So when I run this, of course, what is SQL Server going to do? It's just going to fall back on covering 1 once again, because covering 1 still seems to be the best index to satisfy this particular query, even though I want to seek on salesperson ID. And now you will notice an interesting aspect, that while we are seeking on customer ID, it comes in seek predicate. There is another section that gets added. This is called as the residual predicate, which means predicates on which the optimizer was not able to seek on, and that is salesperson ID. So you have the 2 sections that show up here for this covering 1 index. And but then let's turn the tables a bit on the optimizer, and now let's create another index called covering 2. And this time we will say we're telling SQL Server that I want to seek on salesperson ID, so let's include both of them in the composite key formation. And this is where things get a little complicated now, because the order of columns do matter. So now let's go and execute this, and let's free the proc cache just to be fair that nothing is picked up from the cache. And we will run this query again. Now many of you might think that covering 2 will be used because we are seeking on both the columns, and both the columns are part of the key formation there. And let's go and execute this. And when you go into the execution plan, yes, it is a seek, but if you take the cursor over this, and yet again it only goes for covering 1, it does not go for covering 2. The plan is the same as what we saw last time. Covering 2 is not getting picked up because if you look at the operators there, they're both relational operators, and because in a multi-column index, it always follows, SQL Server will always follow the left-based subset mechanism, which means the traversing will be from left to right. And because there is no equality operator in the first column, it will not be able to seek on the second column. Well, call that as the rule of the optimizer, but this is how it works. Because there is no operator here, equality operator, you can't seek on salesperson ID, which means this will again become a residual predicate and you will be able to seek on customer ID. That's why SQL Server falls back on covering 1 and it does not use covering 2. But what if you just change the query a bit like this? Let's say, just for the purpose of explanation, customer ID equals to 1 and salesperson ID equals to 1. Well, we understand that functionally it changes the meaning, but I'm just trying to technically explain you what happens behind the scenes. And when you execute this, and now you will see that SQL Server does use covering to index. And now you can see that there is no residual predicate section here. It's just not there, and you only have seek predicates, and this time you're seeking both on customer ID as well as salesperson ID, and this is what you had actually expected, but it doesn't work with this one. And also this time, when we're playing around with indexes, look at the number of reads. When we were scanning the entire table, we were touching like 700 pages, and that was the IO. And now because of these covering indexes, the IO has reduced drastically. So of course there's a lot of performance improvement here, but please do not generalize that you just got to go ahead and create as many non-clustered indexes as you want. That is something that you should not do, because with every non-clustered index, you are actually affecting DML performance. So let's go back and where were we? We were actually playing around with this one. So I'm just going to run this again and go and look into the execution plan, and yes, covering 2 is getting picked up. Now let's come to the point. Now we were talking about the sort order here. So when you look at covering 2, just scrolling back a bit, when you were creating this covering 2 index, the data was sorted by customer ID, salesperson ID, which means the sort column is customer ID here. And it works pretty well because you're also ordering by customer ID. So this is really good, and it just works amazing. But what if the requirement changes and you are sorting by salesperson ID? Now for the customer that I was talking about that inspired me to create this video, this is from this point things were getting a bit trickier. So now I'm ordering by salesperson ID, and remember, salesperson ID is not the first column in covering 2. So what will the optimizer do? Let's go and execute it. Now remember, you are just not getting any data there, so it's just a blank result set. If you go into the execution plan, and you will see that SQL Server does pick up covering 2 because this is the closest match, but you might have expected some sort here, so don't get misled by this. This is not the same. Because you're not getting any data here doesn't mean that this is the perfect index, because you're ordering by salesperson ID, and this ought to be the first column. So I played around a bit just to reproduce the problem, and when I look at the data, and this is how the data looks like. There are a lot of customers like 1, 2, 3, so on and so forth, and there are salesperson IDs like 280, 283, 275. So earlier I was ordering with this, and because the data is already ordered in this fashion, you can see 1, 2, 3, but this is not ordered 280, 283, 275, so on and so forth. This is how the data is laid out in the index. So what I will try to do is let's scroll down a bit, and I was trying to put salesperson ID as 280, and now if I execute this, I'm just trying to get some result set. Remember, this was getting me a blank result set. Let's go and execute. I'm getting a blank result set. There's no sort operator. Everything is done by the index. All good. But now if I try to get some data, and I'm getting 4 records, and I go into the execution plan, I still see index C, covering 2 is being used. Absolutely fine. But remember, there's no sort required here because all the values are still 280. What if I get multiple values, 280, 283, 275? Well, remember, there is an AND criteria here. So this result also is just going to get me 4 records. And because the data is already sorted by salesperson ID in a way, because these are just duplicates, I again don't need a sort. But now comes the tricky part. What if you actually had data? Now I'm seeing customer ID in 1, 2, and 3. And salesperson ID is either 280 or 283 or 275, and if this combination is true, I'm getting multiple records, and now I'm actually sorting salesperson. I'm sorting the data by salesperson ID. You can see 275, 80, and 83, and this is not sorted because I sorted by this. Now if you go and look into the execution plan, wow, you are spending 78% of the plan cost with this excessive extra sort operator being added. So what is SQL really doing here? SQL is actually doing a full seek on both the columns. There is no residual predicate here. It is actually seeking on both the columns. It's using covering 2. This is what we want, but this extra sort creates a bit of expense. Not a bit. If this was large data, this would be a lot of expense. And that is what that is the point that I'm trying to highlight, that order of columns in your index does matter. Order of columns in your query, in your select list, it does not matter. So to get rid of this sort, all you have to do is just reverse the index, right? Index columns. So I'm going to create another one called covering tree now, and I put salesperson ID first and then customer ID later. Well, this will make a lot of difference in your query performance. And now when I execute this, get the index ready, and let's go and execute the workload again. You get the data, and let's go into the execution plan. Perfect. And this time there's no sort operator, as you can see, and which index is being used. The optimizer does a beautiful job, and covering tree gets picked up. Now this is important. You know why? Because so the customer that I was actually referring to, all that they cared about was that, you know, either my indexes are being seeked upon or not. Yes, index seeking was happening, but they were kind of ignoring that expensive sort operator, which could have been easily fixed by just reversing the columns, and yet you get the same index performance that you expect, and you get rid of that extra sort. So that is why this video was titled as index sort order. Now, whether you call it as index tuning or query tuning, well, really doesn't matter. You're tuning the indexes, and the result of that is your query gets tuned. So let's just go and do a cleanup and delete all the 3 indexes there. Well, let's get back to the slides. Hope the demo was useful and you have learned something new. Here are a few bullet points about me. In short, I have been working with SQL Server since 7.0. It has been more than 20 years and I still love working with the product. There is a URL there, sqlmaestros.com/Amit-Bansal. Click on that and you can read and learn more about who I am and what my work is. And you can see a few pictures from our last year's conferences. More than 1,000 people join Data Platform Summit each year from more than 20 countries. Microsoft product experts from Redmond, India, China, Israel, Dublin, MVPs from more than 16 countries, and industry veterans. They deliver more than 100 breakout sessions, open talks, and chalk talks at this conference. We have exclusive learning formats like even roundtables and hands-on labs. And if you're serious about Microsoft Data Platform and SQL Server and the complete Azure stack, this is a signature event that you should not miss. You can visit dps10.com to learn more about this conference, which has been promoted even by media and online websites as one of the largest community-driven learning events of Asia. Well, then thank you very much for your time for watching this video. I hope to meet you again soon in another video.